Well, as you can see, I've been doing some winding with these bobbins per one of my other videos. And they are cheap and they are easy. And the nice thing is that you can wind these to a very high precision. I was aiming for 512 microhenries on one of them, and I came up with 519. And when you buy commercial ones, usually it's like plus or minus 10 unless you go pop for the expensive ones. So that was really good. So what I did is I wound up this one and this one are for an inductively tuned type of radio. This was an all-in-one attempt, and this one over here is an exact copy of a coil for another radio. Let me zoom out and I can show you what I'm talking about. There we go. Okay, get those out of the way. On this radio, I was trying to emulate this coil using these, like that. And what we have is on this tap over here, we have the antenna. The second tap right there goes to the ground over here. The third tap basically goes to the headphone circuit. And the last tap goes to the other side of the capacitor. And of course, all the other things are grounded over here too. So what I did is I measured this, how many microhenries it was. It was 205 across here. So I wound these coils to emulate this and put this on here this way. So for this coil, this would be the antenna connection over here. The next connection would be the ground there. This connection where the two coils are tied together, that would be right there. That's the earphone circuit. And then this far wire would be this far wire, and that would be the other side of the capacitor. Okay, so it's all done. It's got the right inductance, and I hooked it up, and all I got was a whisper. So yeah, I've tried this with small core inductors in the past, and they're just too inefficient, and that's the killer. Now the good news is, so that was the bad news. The good news is that if you're working with transistor stuff, you need a coil and you've got a transistorized circuit, these would be great. You can stabilize them with super glue or white glue or wax or something like that to make sure that the coils don't shift around due to vibration. They are, again, inexpensive, they're easy to make, and you can get exactly the type of inductance you want. But again, that's for a powered circuit, not for a crystal radio. For the crystal radio, the efficiency is just too low, and they don't have what it takes. So good news is that these coils do work, but the bad news is they only work for more like powered type circuits. In a previous video, I was talking about this coil that I made, and this coil is basically it's a copy of this coil, but it's been shrunk down. So it's got the same inductance, it's got all of the properties should be the same, only the coil is smaller. And the point was I was trying to make a very portable crystal radio. I said that it doesn't work, and how badly doesn't it work? And I didn't say that in the last video, and I guess I should have demonstrated how badly it does not work. When I hooked this one up, I got, just barely a whisper. It would not even show up on the oscilloscope. So to demonstrate how poor that is, I just took this is a coil that I use for a coupling experiment. It has not been tuned. It is not, the parameters are not for a crystal radio at all. In fact, you can see where I patched it together. So over here, this is a 0.9 millimeter wire, and then there's another patch right in here, and then over here is some 0.8 millimeter wire, and then over here is some Litz wire. And you can see that we're receiving a local station, and I can tune in and out, and I can get a couple stations with this. So there's another station right there. So even with a coil that was not made to be a crystal radio at all, it outperforms this. Like I said, this will not even show up on the oscilloscope. The signal is so poor. So using this as our standard, this gets 4 to 5 stations. This will easily get 2 stations out of just a junk coil. And this, I can't even get a thing on the oscilloscope. So that's how poor it was. You might see some other things back here that I've been experimenting with. I'm still trying to do a miniature version of a crystal radio, and these outperform this. This was not made to be a crystal radio. These are way off in spec compared to what this should be. However, this is not working. Now, what I also should be doing is I should be talking about what went wrong with this. In 7th grade science, I should have known something like only to change one parameter at a time. And when I built this, I changed 4 parameters. I changed the diameter of the core, I changed the length of the core, I changed the winding style, and I changed the diameter of the wire itself. I have failed the basic thing of science, because you only vary 1 parameter at a time, and I went for 4 and it failed, and frankly I don't know which one of the factors caused it to fail. So I think I should do an experiment and find out which of the parameters is causing this. So I think I'm going to wind up some coils. I'm going to use this size of tube. I'm going to use a thin wire on this size of tube. And of course I'll run the calculations for the correct size of wire on this, but I'm going to keep the diameter of the pipe the same and make that a constant across, and then I'm going to try to vary only 1 parameter at a time, and I will see if my assumption that the core diameter was the main problem here. So yeah, one way to find out, we run and do proper experimentation. Here we have the first experiment. So back in this area are my antenna and ground wires, and you can see the black are the ground and the yellow is the antenna. These 2 radios, so why I've got this secondary radio on here is these are actually the same radio. So it has the air core capacitor, same over here. I'm only using 1 bank, so that goes from roughly 0 to 365 picofarads. Same over here. They're both using the same diode, the same earphone circuit, and these 2 coils are exactly comparable, only this one has been wound with very small wire, 31 gauge, and this one is, what is it? It is 0.81, I think, millimeters. So, and this is 0.227 if I recall correctly. So I've got this one hooked up to my antenna ground system right now. And I've just been running comparisons to these, and what I found is kind of interesting. So right now I am listening to one station. It's a little bit scratchy, but you can see it there on the scope. And let's tune through the stations. And still the same station, seems to cover the background. Okay, getting into the next station. That is the guy talking with music in the background. Sounds like an ad. And yeah, that's the loud station in the neighborhood. And then there's another station. So what is that? 1, 2, 3, and 4. And the interesting thing about this coil is it covers on the transistor radio from a little over 100 on the dial to somewhere about 600 kilocycles. So yeah, it's not perfect. It probably means I've got too much capacitance and maybe not quite enough inductance, so it's not reaching each range. But yeah, so this is perfectly acceptable. This radio gets about 4.5 stations, and this is doing pretty much the same. It's getting 4 stations pretty well. This one is a little scratchier. The sound is a little scratchier. This one, the sound is a little more melodic. But last night I was actually getting 6 stations on this one when I can only get 4 on this. Yeah, I don't know if it's what the conditions are, why it would do that. But This would be totally acceptable if you were looking for a smaller radio as opposed to a bigger one. This one, it has a little bit better sound in my opinion. The quality of sound is a little better. This one's a little bit scratchier. So what we know is that this core is exactly the same size as this core because they were cut off the same piece of pipe. And the coil windings have been ratioed and done calculations to be exactly equivalent. So we know that the size of the wire is not the issue when it came to this bobbin thing not working. So the next experiment is to vary one of the other parameters and see if that causes the coil to misfire. Okay, so again, summary on this experiment. Given the core is the same size, the diameter of the wire can be much smaller, and it still works okay. So diameter of the wire was not the factor that caused the bobbin winding not to work. Okay, next experiment. This coil is a downsized version of this one where the first part is the antenna. So from here to the first tap. From the next tap here is the earphone circuit. And then from this tap to this tap is the part that goes through the capacitor, and it is actually the part that gets tuned. So this radio works very well, and again I want to imitate it. So this is our standard from which we're going to work. And yeah, so all the other coils are going to be wound from that. So the next variable I wanted to test for was the scatter winding. So the scatter winding of the bobbin coil, was that the issue? Is that why it failed? So I made a scatter wound version of this core, using this core rather, same size core. And yeah, what a scatter winding is where you go back and forth at random when you're winding the coil instead of being this nice beautiful winding after winding. This one just goes back and forth. Now the trick to this is there's 3 sections of this coil, and you have to scatter wind each section, and you have to keep it in its own little zone. So there's one here, there's the next one for the earphone, and then there's the next one that's the tuning. The details for this, the amount of wire I use, the turns, all that stuff will be in the description, of course. This was a bear to do also because, not just because of the scatter winding and trying to keep everything in its zone, but because I had to glue it in place. The wire is very thin and it does not like to hold a shape, so it liked to come right off of that core. Required a lot of patience, a lot of winding and unwinding, yeah, and rewinding, so yeah. The scatter winding is a type of multi-layer winding, so if the scatter winding works, then we can be pretty confident that another type, just like a straight back and forth multi-layer, will also work. If this works, if this version on this core and this size and this wire, it works, then we can be pretty confident that the scatter winding on our bobbin core was not the reason that coil failed. Okay, so enough of that. Let's get over to the workbench and make this happen and see what it'll do for us. Okay, let's look at the performance of this coil real time. So we can compare it to last time. My opinion is, and that's based on trying to listen to the same stations at the same time of day to make sure the power output's the same. But overall, I would say they're pretty close. The straight wound coil may give me a little bit better performance, but it's really, again, hard to tell. It's not a huge difference. I would find this scatter wound coil perfectly acceptable if I wanted to make a small radio, which is one of my objectives in the near future. Once again, the core here is the same size as this one. This is our known coil. Let's run over this quickly. These are configured to be exactly the same except ratioed out because of the wire size and the fact that this is scattered and this is straight. But over here we have the antenna going in, same on this side, the antenna going in. The next one is this black clip, which is our ground wire, same as on this side. The next tap point is one side of the earphone, which comes here. It's also where our oscilloscope connects, one of the connections for that. And then on the far side over here we have a capacitor and then That's far side over here is to the capacitor, and of course the capacitor has a ground. The earphone has a ground, comes over here, and then the ground on the coil also comes over here. So yeah, let's tune through the stations, see what we get. This is all the way with the capacitor all the way maxed out. Guide talking, you can see that there. A little bit stronger. Okay, guide talking. Yeah, perfectly audible. This is the strong station, which kind of like wipes out everything else around it. It gives background noise all across the band, unfortunately. There's a woman talking. There's just background noise. There's a very, very faint station. Very faint. Another one. Guy talking. Oh, no, that's the same one right there. Okay. That one. And then I'm trying to get another station. I think that I've got too much capacitance in the system because I should be able to keep tuning. I'm not covering the whole range of the dial. Yeah, so I'm not getting across the whole dial. So that's usually indicative of too much capacitance, too much inductance, and you know you're not being able to get off both ends of the band. But yeah, this coil is perfectly usable. It would require some tuning. I mean, if you wanted to cover the whole band. But especially if you're going for space saving, I mean, you can compare it to this, and you could cut this way down and make a much smaller coil out of it. I would find it perfectly acceptable, you know, if I were trying to make, say, a bug-out bag radio, something like that, an emergency radio, or I need to keep it in a drawer or a little box or something. I pull it out in case there's a power outage and I need to hear what's going on. But yeah, perfectly okay. Not my first choice, but perfectly okay if I need the size consideration to bring it down to make it a more portable device. Okay, well that was it for this scatter wound coil. The difference between these two coils, the core diameter is different. This is a 1.5 inch water pipe, and this is an 8mm sewing bobbin. Yeah, this did not work well. It barely gave me a whisper in a crystal set. It would work fine in a powered set, but not so much in a crystal, and the question is why? What about this is not making it work right? We eliminated wire size, we eliminated the scattered versus the straight windings, and finally the only thing left to test is the core diameter. So obviously the core diameter on this one is much bigger than this. So the last test was something I was dreading doing because, as you can see right here, this is 864 windings if I remember right. It's 19 point some meters of wire, and yes, wrapped by hand. It was very, very fun. But again, it's just another ratioed version of this, so this is our standard. And here is the antenna part, and then the next connection is the ground. The next part here is the earphone circuit, and then this is the part that is capacitively tuned. So that's one side of our capacitor, that's one side of our earphone, and again, the other side of those are the ground right here. So, yeah, what we need to do is we need to go over and hook this up to the antenna and to the radio workbench and see if the smaller core is the issue. And yeah, if this works, I don't know where we're going to go. We're going to have another video. But if it doesn't work, and I strongly suspect this is going to be the problem, yeah, if it doesn't work, then we know that small core is bad for crystal radio. Okay? Well, enough talk. Let's go hook it up and see what it'll do. Well, here we are all hooked up. This is the ground. We got 3 grounds back here. One of them is capacitor ground, one of them is coil ground, and the other is the earphone ground. Moving on around here, we have the antenna connection, and it comes over here. So that is our first connection right there. The next connection is our ground, which is one of these wires back here. This green wire is the one side of the earphone circuit, and this red one is the capacitor. So it's one side of the capacitor, and then here's the ground on that. So that's it's very typical setup if you've seen my other videos. Back here is our oscilloscope, and it's grounded there, and then it's connected to the diode right there. So that's it. It's time now to tune through it and see what this circuit is going to do for us. You'll notice that it's pretty much flatlined. I normally am getting static right about now, and wow, it's just like nothing, quiet. There is the station. It's about 1 kilometer from my house, and yeah, that's all I'm getting. Keep going, and nothing but more static. So yeah, I'm getting one station, and frankly I can get one station with just a diode, an earphone, antenna, and a ground circuit. So winding this, taking the time to wind this massive coil, time and aggravation is not worth it. But the point of this experiment was to determine if the core diameter was the issue in our bobbin coil, and it certainly appears that that is it. So moral of the story is, if you are doing crystal radio coils, bigger is better, and when you start getting this small, it's just not going to work. It would work fine in a powered circuit, you know, where you got transistors and amplifying the signal, but as far as a crystal radio goes, yeah, it's just too inefficient to work. Okay, well that was it. Hope you found that useful and interesting in your crystal radio experimentation.